Alright, so in this video we're basically going to put all the information together into one final shot here. Okay, so we've talked about already how to find most of this information. So when we're doing this, we need to find a few things first. We'll start with domain. Well, first let's look at, can we cancel anything out? No, not immediately. Can we factor the numerator or the denominator? No. So now we need to figure out the domain value that's not going to happen. So here, the problem with the domain is any x value that makes me divide by 0. So if I go to the denominator, and then if x were to equal 1/2, we would have an issue. I'm not going to actually show myself solving that. But if x were 1/2, then we would run into a problem, because that would make us divide by 0. So my domain is x is not going to be 1/2. If x cannot be 1/2, and we don't, well, let me move down to point of discontinuity. I should have done that first. So if nothing cancels out, so if we look at the beginning, we cannot factor the numerator, we cannot factor the denominator, and nothing automatically cancels out since we can't factor it, we will not have a point of discontinuity. So now, since I know that x cannot be 1/2, and I know that there's no hole or no point of discontinuity, my vertical asymptote is going to happen. Well, I kind of got my own way. My vertical asymptote is x equals 1/2. So since I know it can't be a point of discontinuity because nothing canceled, but x cannot be 1/2. So the domain restrictions, the x cannot be 1/2 is either a point of discontinuity or a vertical asymptote. And again, I know I said this 1,000 times, but since it's not a point of discontinuity, it has to be an asymptote. It's one or the other. So if I know, well, let's do all the definitions before we graph it. So horizontal asymptote. So horizontal asymptote was our last video, and we look at the degree of the polynomial. So the degree of the numerator is 1. The degree of the numerator is 1. The degree of denominator is also 1. So if they are the same, we divide the coefficients. And the coefficient of the numerator is 2. The coefficient of the denominator is also 2. And 2 divided by 2 is 1. And the coefficient is the number next to x in this case. So it's 2 for both of them. So my horizontal asymptote happens at y equals 2. Again, for horizontal asymptote, you're looking at the degree of the numerator and the degree of the denominator. So now we're moving on to x-intercept. And the x-intercept we have to solve for. So the x-intercept, here, let's do it on the other side. The x-intercept, we set the numerator equal to 0. Numerator is the top of the fraction. So we set the numerator equal to 0, so x equals negative 1/2. So my x-intercept is negative 1/2, 0. So the x-intercept, we set the numerator equal to 0 and solve for x. The y-intercept, I don't know why I double colon, that's typo, but the y-intercept is we plug in 0 for x. Because the y-intercept, the y-axis is where x equals 0. So we plug in 0 for x. So we have, here, let's do it below. 2 times 0 plus 1 over 2 times 0 minus 1. So we have 1 over negative 1, which is negative 1. So my y-intercept is 0, negative 1. So I'm going to highlight all our relevant information. So I have that. So I have a vertical asymptote at 1/2. So now to actually graph it, we're going to go to 1/2 and draw a vertical asymptote. And since that's not perfect on a line, it's in the middle. I have a horizontal asymptote at y equals 2. I have an x-intercept at negative 1/2, 0. So right there. I have a y-intercept at 0, negative 1. And I don't have a hole. So I'm not grading you on perfection here. We're going to have a curve here. And then we're going to have a curve in the opposite corner. So they're always going to be opposite of each other. And based on the x and y intercept, I knew to start in that third quadrant right there. So find your asymptotes and your intercepts. And after you find your asymptotes and intercepts, just graph it. The next example, I only have two. The next one's a little more involved because we need to factor the numerator and factor the denominator to see if anything cancels to give us a whole. So I'm going to do that real quick. I'm not going to go over the factoring stuff just for time's sake. I don't want this to take forever. So I'm just going to factor the numerator and denominator. All right, so after we factor the numerator and denominator, we need to look, does anything cancel? So as soon as we look, does anything cancel, my x minus 1s can go away. So I'm just left with 2x plus 3, x minus 4. My domain restrictions are any x value that I plug in and cause problems. So when I factored, I have x minus 4 and x minus 1. So if x equals 4, we have a problem because 4 minus 4 will force me to divide by 0. Also, if x equals 1, we also have a problem. So if x equals 4, we divide by 0. Or if x equals 1, we divide by 0 for both values. So if we divide by 0 for either value, we divide, which that can't happen. So in this case, x cannot be 4 or 1. Both of them are bad. We know that x minus 4 did not cancel out. So x minus 4 did not cancel out. So vertical asymptote is going to happen at x equals 4. The x minus 1 did cancel out with something in the numerator. So that is going to be my point of discontinuity. And if we crossed out x minus 1, if x minus 1 is what canceled, then the x value of the point of discontinuity is 1. If we remember back for how we found these, if the x value is 1, we plug that x value into the leftover equation. Because if we plug it into the original equation, we divide by 0, and that's no good. So we plug it into the leftover equation. So we get 2 plus 3 over negative 3. So we get 5 over negative 3. So my whole is going to happen at 1, negative 5 over 3. It doesn't matter where the negative sign goes. Okay. My horizontal asymptote, we look at the degree of the numerator and the degree of the denominator. I have x squared up top and x squared on bottom. So that's the same degree. The degree of the numerator is equal to the degree of the denominator. So if they're equal, we divide the coefficients. The coefficient of the numerator is 2. The coefficient of the denominator is 1. And 2 divided by 1 is 2. So my horizontal asymptote, we divide the coefficients because they're the same. The degree of the top is equal to the degree on bottom. So we divide the coefficients, so we get 2. The X-Intercept, which I'll do in a different color because I'm going to show my work. X-Intercept, we set the numerator equal to 0. And then solve for x. So x equals negative 3 over 2. So my x-intercept is negative 3 over 2, comma 0. So again, the x-intercept, you set the numerator equal to 0 and solve. Y-intercept is where we plug in 0 for x. So we go to the equation, and everywhere we see an x, we replace it with 0. So in this case, we get 3 over negative 4. So my y-intercept is 0, negative 3/4. Now that we've filled out all our information, we just need to go put it on the graph. So I have a vertical asymptote at 4. So let's graph that. We have a horizontal asymptote at 2. So we have a vertical asymptote at 4, a horizontal asymptote at 2. We have a point of discontinuity or a hole at 1, negative 5/3, which is basically 1, negative 2. So I'm going to put a circle where the hole would be. I have an x-intercept at negative 3 over 2, 0, which is negative 1.5. And I have a y-intercept at 0, negative 3/4, which is right there-ish. And then again, I'm not grading you on how beautiful this is, as long as the relevant information is where it belongs. So I connect the dots down there, and then I know it's in the opposite corner, so just kind of guesstimate what that would look like. We're not plugging these into the calculator and getting the exact graph because the calculator does a terrible job of graphing these. So when we're graphing, we need to fill out our relevant information that's on the left, and then we just apply that information to the right. And the test will look very similar to these questions. I'll give you an equation, I'll ask you all these definitions, and I'll say graph it. So make sure that we have these notes down, because I'll go over it again in class. But make sure you have these notes down, and if anything's confusing, come to class prepared to ask me questions while I'm going over it.